All right. Good morning. Thank you again for joining us. I am Melinda Dinnan. I am with California Electric Homes, and I'm thrilled to have you all join us this morning for our Heat Pump Essentials workshop. We're going to start with some introductions, and while we are introducing ourselves, I'm going to launch a poll so you can share more about who's joining us. So thank you in advance for completing the poll.
Hi, everyone. Good morning. I'll go ahead and introduce myself. I'm Ari Usher, a project manager at Association for Energy Affordability, and also the multifamily technical assistance provider for the CalEHP program. Nice to be with you all today. And I'm joined by my colleague, Hannah.
Hi, everyone. I'm Hannah Lyons-Cavazos. I'm a project associate at Association for Energy Affordability, mostly working on the build program there.
Super. And I'm Melinda Dinnan. I'm a program marketing manager with California Electric Homes. And I wanted to thank everyone who responded to our polls. Most of our attendees today are builders and developers, so that's fantastic. All right. I'm sharing with you today's agenda. We are going to get through each of these topics in the next 50 or so minutes, and we'll have an opportunity for folks to ask questions as we go. So I'm going to get us started with a brief overview of our California Electric Homes program. All right, so California Electric Homes, which is also affectionately known as CalEHP, offers incentives for the construction of market rate all electric buildings and the installation of energy storage systems and technologies that would not otherwise be constructed or installed. The program is funded by appropriations authorized in the California Budget Act of 2021 and is administered by the California Energy Commission. This slide here talks about eligibility. So it's the entire state of California, single family, duplexes, triplexes, multifamily, ADUs, modular, and manufactured home. We have something for almost everyone. So briefly, I'm touching here on program eligibility. These items listed here are the requirements that projects must include for the projects to qualify for incentives. So the primary message here is that the buildings need to be all electric with no gas hookups and install heat pump space water heating and cooling, induction cooking, thermostatic mixing valves, segregated circuits, and communicating thermostats. I think this might be the most important part, the incentives. So these are the base incentives that are eligible, that projects that enroll are eligible for. So incentives are paid when the project receives certificate of occupancy and completes. So if your project enrolls in the program in 2025, but does not complete until 2027, you can see the incentives would be for a multifamily project, $1,400 per unit. And again, this is per unit. So if your building has 100 units, you're going to multiply that by $1,400. We also offer energy storage incentives that are paid per kWh that is included in your project. And we also have bonus incentives. So there's so many opportunities to really accelerate your per unit incentive. Are there any questions about the slides I've just shared? All right, well, then we're going to move on.
Thanks so much, Melinda. Yeah, I hope everyone's feeling jazzed up about the incentives. This is a great program. Um, and today's webinar is we're really going to be focusing on heat pump technology. This is really the cornerstone of all electric building, doing that efficiently with heat pumps. So I'm going to start off just taking us through some heat pump and building electrification trends. First of all, as folks may be familiar with, California is leading the charge towards a clean energy future, and all electric housing is a big part of that vision. So here's some goals and a timeline that leads us. I'm going to start over at the end. 2045 is the big goal year. Statewide, 100% carbon, zero carbon electricity, and statewide carbon neutrality done equitably. So how is the state going to get there? By 2035, California will be phasing out the sale of new gas-powered vehicles. And electric vehicles, you know, they are a big part of our electric buildings. Electric buildings are really not complete without charging infrastructure to accommodate these EVs. 2030, moving back, that's another big goal year. 50% renewable electricity, double energy efficiency for our buildings, and 6 million heat pumps installed statewide. That's a big goal. That's done both through market transformation, but also really supported by our state energy codes. So this is huge for housing. And I'll talk a little bit more about energy codes in the next slide. But just kind of to overview where we are now, this all electric push is really being helped out at the local level and at the air district level, as well as through incentive sources. There are, you know, quite a few funding sources really around incentivizing all electric housing. Yeah, and just that 2022 was another benchmark year when Energy Code really started favoring all electric housing. Let's take a look at the next slide for the new Energy Code updates here. So just briefly, since this is upcoming, 2025 Building Energy Code was adopted this year, and it is going to be in place as of January 1st, 2026. I wonder if folks are already familiar with some of the big ticket items here, but I just want to highlight that 2025 Energy Code supports efficient electrification for new residences in a number of ways. The first is that heat pumps is the baseline now for space and water heating for all new residences. That means the building that any new building is compared to has heat pump water heating and heat pump space conditioning. And mixed fuel is only a prescriptive option in certain climate zones with certain exceptions, you know, going forward. It's still possible to build mixed fuel using the performance method and taking some penalties and trade-offs. However, there are mandatory electric ready requirements for all combustion appliances for housing. So this means that space heating, cooktops, clothes dryers, individual water heaters, and central water heater systems, if elected to build mixed fuel, they do have to have electric ready requirements, which includes capacity at the service panel. It includes pre-wiring. And for water heating, it includes dedicated space for the future water heater with ventilation requirements as well. So these are pretty substantial and really kind of makes folks think about installing all electric, you know, from the get-go instead of mixed fuel. Just want to also highlight Energy Code does continue to kind of expand solar PV and battery storage standards. There are PV requirements for all new housing starting now, and there are battery storage requirements for high-rise and mixed-use multifamily buildings. There are also battery-ready requirements for single family. And then just briefly on ventilation standards. I'll talk a little bit more about that later, but I wanted to mention this is really an energy efficiency increase. HRV, heat recovery ventilators, are going to be the standard now in most climate zones for indoor air quality. So that's kind of one big change. Now, a couple policy updates. Folks may have heard of AB 130. AB 130 includes a temporary freeze on new residential building codes. So this is effective October 1st, 2025, all the way to June 1st, 2031 for 6 years. So it freezes residential building codes at 2025 cycle. The 2025 energy code was already adopted when this came into law. What that means is that we're skipping the 2028 code cycle for residences, and then the next changes will be allowed at 2031 code cycle. So we have this code for 6 years. And exceptions are existent for certain things like emergency standards, fire safety measures, and home hardening. And the other policy update to make you all aware of is Executive Order N2925, which is really around wildfire rebuild efforts, offering some exceptions from solar PV and battery storage requirement, and also provides an exemption from the 2025 code for those specific wildfire rebuild properties. So next slide, the all-electric future is really here. Just in quick summary, many jurisdictions have passed or are considering policies that favor all electric. California Energy Code favors all electric heat pump technology. And starting now in California, new gas infrastructure does risk becoming a stranded asset, may be hard to replace down the line as gas equipment is phased out at the point of sale. And as building electrification accelerates, fewer and fewer gas customers will be sharing the burden of fixed system costs. So gas rates could really be going up. Yeah, briefly, any questions around this context?
We have a question about incentive amounts that came up. It doesn't really tie to this section, so I'll address it at the end. Super, let's move on to our next section.
Awesome. I'll hand it off to my colleague Hannah to take us through some heat pump basics.
Perfect. Thank you, Ari. Awesome. So yeah, I'll take us through some of the fundamentals of how heat pumps operate before we get into a little more technical information later. So what is a heat pump? Simply put, a heat pump is just any device that's moving heat from one place to another using refrigerant. So whether you know it or not, you're already using heat pumps on a daily basis because your refrigerator is a heat pump. So it's using refrigerant inside the coil to move heat from inside the refrigerator into the kitchen. And that's why you can often feel like heat and warm air at like the bottom or the back of your fridge, depending on like where those coils are located. A water fountain that dispenses cold water is doing the same thing. So it extracts heat from the water to cool it down, and then it's exhausting that heat as warm air at the grill that's usually on the side. A wall air conditioning unit is moving heat from the indoors to the outdoors. And a heat pump water heating unit, which you can see on the right side of this slide here, is a unit that's moving heat from the surrounding air into the water and then exhausting cool air back out. Great, so here we have a simple diagram of what is happening inside a heat pump. So there's a compressor that is compressing the refrigerant, and that's going to allow it to release heat. There's then an expansion device that's going to lower the pressure that's on the refrigerant, and that's going to allow it to absorb heat. So this is just happening over and over in the cycle. This is what's allowing it to move heat from inside to outside or to redistribute heat internally, to move heat from air to water, etc. Essentially, this cycle is what is allowing the movement of heat from one place or one substance to another. So great about heat pumps. So they are hyper efficient, which means that they're 3 to 5 times as efficient as like a comparable electric resistance or gas appliance. And this is primarily because they're moving heat from one place to another rather than actually generating heat. Unlike propane or gas appliances, they can enable zero emissions buildings. They can run on carbon-free electricity when paired with something like solar PV and battery. They improve air quality because we're not needing to burn fossil fuels on site, so there's no localized emissions. It eliminates the need for the installation of gas lines and the associated safety hazards that go with those. They provide heating and cooling within one system rather than requiring dual systems, and they work well in different climates. So something that people might be aware of or think if they interfaced with like earlier forms of heat pumps or heat pump technology is that a lot of those earlier models did not perform well in colder climates. This is really not like an issue that's at play in the contemporary market because of sort of the proliferation of cold climate heat pumps. Most cold climate heat pumps are designed to operate very effectively below 0 degrees Fahrenheit. In California, we're not really running into temperatures that low generally to begin with, but this is good to keep in mind if you do work in markets outside of California, that there are good heat pump options for those areas as well. Do we have any questions?
I think they're saving them till the end, so we can move on.
All right, I'll hand it back to Ari then.
Yeah, moving right along. We're going to get into the specific equipment options around space conditioning. So first, I'd like to talk about air source heat pumps individual. This is usually the choice for specific dwelling units, individual systems at a one system per one unit kind of cadence. And there's a lot of options here. Folks may be familiar with these, but I'll just take us through them. First, a ducted heat pump. This is, on the far left here. It looks a lot like an air conditioner, and it does provide air cooling and air heating as well, though. But that's, kind of a larger form factor heat pump outdoor unit paired with an air handler unit and ducting to each of the different spaces. If we're looking at split systems, the more efficient option is going to be your mini split heat pump. The mini really refers to the small form factor of the heat pump itself. You can see there in the photo that this is, about the size of a suitcase, easily sited up on the roof, or kind of wherever you've got room for it. And this can be ducted or ductless. So it's going to, in general, mini split ductless is going to be paired with an indoor fan coil unit. There are a lot of different types of delivery mechanism that you can pair this with, though. It can be ducted as well. There are also multi-split options where you have a single heat pump paired with multiple indoor heads, which is a great option for kind of minimizing the number of total heat pumps. There are also packaged options that can work on an individual dwelling unit basis. These technologies have the heat pump, compressor, the fan coil, and everything kind of in one single piece of equipment. There's a couple different options. You may be familiar with the vertical terminal heat pump, also called VTAC, or packaged heat pump, sometimes called PTAC, or more appropriately PTHP, also room heat pumps. So there are a lot of options here, and I think contrary to maybe earlier on in the market, these systems can be inverter driven. They can be very efficient, and they also are a really good option for kind of smaller units, because the thing here is you do have to have one of these units for each of the spaces in the dwelling unit. So when you're looking at maybe 3 or 4 bedroom homes, it becomes a lot of equipment. But in terms of smaller units, these are great because all the equipment is located inside the unit. It's easy to maintain and it saves space on the roof. The other thing is you do get the ability to do room by room control, which is great for energy efficiency. So also want to address our central or common areas. There are heat pump options for these spaces as well. The variable refrigerant flow is a great system that is kind of like the central version of a mini split. It pairs a heat pump with multiple indoor fan coil units. And the cool thing about VRF is it can provide simultaneous heating and cooling to the different spaces. So if there's a room close to the exterior with a lot of windows that's getting a lot of sun, it might need cooling. A different space, closer to the core of the building may need heating at the same time, and VRF can do that. But the thing to think about is there's a lot of refrigerant in this system. So whenever we have refrigerant, we also risk refrigerant leakage. It's just the nature of the equipment. But we do see these a lot for, like, for example, office suites or property management areas in the building designs that we take a look at. There's also kind of a standard packaged rooftop heat pump. This is your typical built-up RTU that has the heat pump and the air handler all in there. And then it's going to be paired with ducting to serve the different spaces. Also want to mention that there's a heat pump option for tempered air as well. So often dedicated outdoor air systems will be used for example, corridor ventilation, providing tempered outdoor air for ventilation purposes, and their carrier and many manufacturers have heat pump options for DOAS systems. So let's also talk a little bit about air-to-water heat pumps. I did just cover our air-to-air heat pumps, but there are a lot of products either available now or coming soon that are in the air-to-water realm. These heat pumps actually take heat from the air, and then they actually transfer that heat to water. We've got a poll question here, so as I'm talking, please take a minute to fill this out. I want to know if anyone here has included air to water space conditioning in any of your projects so far. These are great because they can provide multiple end uses with a single piece of equipment. Since you are working with hot water, you can get space heating and water heating in one system. And some of these systems can even provide space heating, water heating, and space cooling in one single piece of equipment. Let's take a look at how it works on the next slide.
I'm glad we're covering this because most of our attendees today have not yet included this. So I'm excited to learn more. Thank you.
Yeah, and we did want to cover that just for this reason. There is really an influx of these kind of products on the market. And they work by pairing hot water with either a hydronic fan coil or a radiant flooring or radiator kind of option. So this diagram really shows, you see kind of your heat pump outside, and then it's paired with an indoor unit. We've got like a kind of control box. And then we've also got a tank for hot water to be stored for domestic hot water use. So this single heat pump is going to be providing, both hot water for space conditioning and for domestic hot water. It also can provide cooled water, chilled water for space cooling. So if you look at kind of the red and blue lines here, that's hot or chilled water. And coming up to the second floor, you can see either paired with a radiant hydronic fan coil unit. So the air blows over the hot or chilled water to provide space heating or space cooling. There's also a radiator option. You can see the hot and cold water lines moving to kind of a radiator option. And of course, for space heating, a nice option can be hydronic radiant flooring, which you can see kind of the snaking lines of hot water under the floor, under the flooring material there. Yeah, so I wanted to plug that the CalEHP does have technical assistance available. If you have questions about air-to-water heat pumps, the technology itself, or incorporating this into some of your projects, I would just encourage you to enroll in TA. It's a free resource that Melinda will be talking about a little bit more later on, but we would be more than happy to talk to you about air-to-water heat pumps. Yeah, So as we kind of finish up this space conditioning section, if you're going to kind of take away anything in terms of selecting equipment, I want you to think of these technology takeaway points in that case. So for energy efficiency, we really want to make sure that we're driving those utility costs down for the residents. That's going to be a key factor in appealing to future residents. For air-to-air heat pumps, the biggest thing to consider is a inverter-driven, or otherwise known as a variable capacity heat pump. So rather than kind of a standard single stage or even a multi-stage heat pump, inverter-driven heat pumps offer efficiency boosts. So this can really reduce short cycling of the equipment. And it also provides greater design flexibility with the smaller footprint that we discussed. But really the key factor here is this is going to help keep those utility costs low. Another energy efficiency thing to consider for space conditioning is really around indoor air quality and ventilation. As I mentioned earlier, the 2025 code is going to really be pushing and supporting for balanced ventilation, which means supply air and exhaust air, or rather a mechanical supply and exhaust. Instead of an exhaust fan only to serve indoor air quality, we're going to be seeing more often that it's required to include a supply fan as well. So an ERV is a piece of equipment that actually includes your supply fan and your exhaust fan in a single piece of equipment and adds on heat exchange as well. So what happens is that outdoor air is going to be tempered as it's coming into the home. And that's going to really reduce the heating or cooling load of the home. So this is an important feature for energy efficiency as well. Yeah. Do we have any questions on space conditioning?
We do. Can you talk about the space and soundproofing required to accommodate heat pump units? This can be an issue in multifamily situations, as heat pumps are known to create maybe more noise than other technologies.
Yeah, this is a great question, and it's definitely something to think about at the design phase. For space conditioning, as we kind of went over, if you've got your split systems, you're often going to be siting the heat pump unit outdoors on a roof. And, kind of luckily, that's not an area where sound considerations are most important. However, there are definitely acoustical insulation solutions and things to be considered during design. And it is something to consider as well for equipment selection, because the specs will always show the sound rating. If you're using, for example, package systems where you're going to have the heat pump in the unit itself, important to review that decibel rating on the equipment spec itself, because as I kind of mentioned, it will vary. So probably the recommendation here would be, in design phase, have that as part of your standard design requirements, maybe set a decibel rating, and then the product selection would need to be below that. But there are heat pumps that have a low decibel rating comparable to a standard appliance like a refrigerator or dishwasher, or even lower.
Thank you.
Great question. So I did see another question come in, which I'm happy to address since we just talked about ERV. The question is there an incentive to offset the cost, which is about $1,000 to $2,000? And I will say that there's not an incentive in CalEHP specifically for ERV. However, it does increase efficiency, so it may be something to consider for an increased efficiency bonus. And maybe Melinda can talk a little bit more about that at the end. Okay, let's talk about water heating. And the first thing to talk about is just the way that a heat pump water heater varies from a combustion water heater. So it combines a heat pump with hot water storage. This diagram just really shows the heat being absorbed from the ambient air and then being transferred to the water. So two things to note about heat pump water heating is the heat source is the ambient air. And number two, they exhaust cold air. So let's go to the next slide. In terms of equipment, you do have options for a split heat pump water heater or integrated heat pump water heater. And let's take a look at what that actually looks like on the next slide. Yeah. So if you're opting for a split system, which is probably not as common, except for in the single family arena, you'll have your heat pump, which you can locate anywhere, combined with a storage tank. If you're going for the integrated tank option, the heat pump is going to be included in the equipment itself on the top third of the equipment, and then you're going to have that hot water storage down below. These have a heat pump, but they also have an electric resistance element that is going to kick on at times when the hot water storage runs low and there's additional hot water demand. So we've got a technology takeaway for you on the next slide, which is to always pair individual heat pump water heaters with a thermostatic mixing valve. So heat pump water heaters may require more storage capacity than their combustion alternatives to maximize energy efficiency. And that's really because that electric resistance element may kick on if the stored capacity is running low. So including a thermostatic mixing valve is going to allow you to set the primary storage higher than the delivery temperature. The storage can be set over 140 degrees Fahrenheit. And what this does is it increases the effective storage volume of the equipment because you get more hot water out of the same amount of storage. So the thermostatic mixing valve, what it actually does is it takes that hot water and it mixes it down to supply temperature, usually about 120 degrees, with cold water. So this really increases the efficiency of the system overall by minimizing the amount that the electric resistance element has to kick on. And as we heard earlier, the electric resistance is, 3 to 4 times less efficient than the heat pump itself. So TMV, always pair heat pump water heaters with a TMV. And this is also a prerequisite for many incentive programs, including CalEHP. Now, I did promise to talk about ventilation. This is the other technology takeaway for a integrated heat pump water heater. Efficient operation is really only going to be ensured by providing adequate ventilation. Now, you don't have to reinvent the wheel because manufacturers do provide really good guidance around required ventilation for their systems, but it is important to note that the install is going to look a little bit different than a comparable combustion appliance. What you don't want to do is put the heat pump water heater in a closet and then shut the door because the heat source, which is the ambient air, will quickly become depleted. You're going to need to allow for ventilation. That cold exhaust air needs to get out, and then warm makeup air also needs to get in. So this can be done a couple ways. If you've got a garage location, that's a great location for a heat pump water heater because it's not going to be enclosed. There will be plenty of ambient air to provide that heat source. If it is going to be sited inside a closet, it really needs to be paired with the net-free area through louvers that's required by the manufacturer. So in this photo, you can see the door is louvered in a high-low application. This is great. The high louver is going to be aligned with the exhaust vent from the equipment itself, and then the makeup air can get in through the bottom. We always recommend a fully louvered door if possible. And the other thing is that you can also do this through ducting, which is probably the most foolproof way to provide adequate ventilation. So exhaust can actually be ducted from the equipment itself directly out of the enclosed space, and then provide a louver for that makeup air. Right, let's talk about central equipment. This is common in some mid-rise and high-rise multifamily buildings, especially in cases where you've got space constraints and there's not enough space to put a water heater for each of the dwelling units. This allows for a central plant to provide water heating to all of the units. And these systems are made up of a heat pump paired usually with quite a bit of storage. But this slide really shows that there are a number of different products on the market. I also want to highlight that there are different capacities as well. So whatever kind of the demand for your building is, there's going to be kind of a cost-effective option to build up the system to provide the heat that you need. There also is an integrated tank option for a commercial application, as you can see over on the right-hand side. But for multifamily buildings, we typically see a split application and a built-up system. So on the next slide, we can see that these heat pumps are really going to be paired with storage tanks. And it's typically more storage than you would see for a gas boiler system. So a couple of technology takeaways for central heat pump water heating plants. On the product selection side, a big energy efficiency boost comes from considering single pass equipment. So heat pump water heaters can either be single pass or multi-pass. And just briefly, that is about what it sounds like. Single pass means that the cold water comes in and is heated all the way up to temp in a single pass. And usually that temp is upwards of 150 degrees. And then multi-pass means that the water comes in and it gets heated up a few degrees, and then it passes through the heat pump again. It gets heated up a few more degrees until it reaches the storage set point. So when selecting equipment, one rule of thumb is single pass systems tend to be more energy efficient, have a higher efficiency rating than multi-pass systems. And then ensuring optimal performance, central heat pump water heater systems, as you can kind of see from the photos, there is a degree of complexity. So it can be important to work with subs that are experienced in central heat pump water heating. Another recommendation is, especially on your first system like this, have the sizing reviewed by the manufacturer or a third party. Couple other recommendations are really to include performance testing scope as part of the installing subs contract. This is important because, oftentimes when subs install this and then their contract ends, if any issues come up, the right people aren't necessarily there anymore. So to find any potential issues, before they become a bigger issue, we really will recommend that startup performance testing scope. And also, some installing subs may offer an ongoing service contract. And we also recommend that there are, regular maintenance items that can be done to ensure the performance of these systems. And yeah, that is kind of the end of the water heating section. So are there any questions right now?
There is a question from Steve Norton. It's a long one. So it talks about larger commercial applications, the cost difference between standard and high efficiency gas systems and heat pump water heating systems that remain significant. So he's asking how to realistically address the challenges that he's listed out here. Do you want to talk to that?
Let me take a minute to fully read this question. Got it. Yeah, it's a fair question. I will kind of point again to a couple of things. Number one, the incentive programs that are available for all electric buildings at this point, really one of the points of those is to kind of address this cost discrepancy. So the incentives are around now, which is really trying to kind of push the market towards all electric. So that's one thing that can help. The other thing is I just want to kind of point again to our energy code, which is, increasingly requiring, if not full electrification, then electric ready requirements. As specifically on the central heat pump water heating side, there's a new requirement in 2025 code that requires electric ready or heat pump ready for central water heating systems. And that means that the electrical capacity already needs to be there. So this is actually a mandatory requirement. You know, it doesn't necessarily bring the cost of these systems down, but what it does is it brings, cost parity with the gas systems, since you already have to do that capacity at the electrical panel. You know, it's definitely a good question, but that would be my answer for now. I also want to plug kind of the technical assistance aspect of CalEHP, which is a free resource. To your second point, really around achieving comparable first hour delivery and performance, and a larger heat pump water heater system, our technical assistance is a good option for reviewing your system and providing any sort of recommendations to kind of like increase efficiency, maybe introducing you to products that you haven't heard of before. So that would be my offering for that.
All right, fantastic. Thank you.
Great questions. Thank you.
Yes. So I'm going to talk a little bit more about no cost technical assistance. It's been referred to a few times. So I just wanted to touch a little bit on who's eligible. And it is available to any project that has an all electric market rate residential housing project team, or mixed fuel projects teams who are interested in learning more about making that switch. Maybe there's some team members that need a little friendly push. Maybe it's a new concept to members on your team. And again, the program offers this no cost assistance with no obligation to enroll your project, and really no obligation to share all the nitty gritty details of your project. We're just here to help. So who can request? We'll leave that wide open. So it can be someone on your project who is currently enrolled or interested in enrolling in the program, or just someone who's really just interested in learning more. So it can be developers, builders, architects, any member of your design team, energy consultants. This is often new to many of them. PERS raters, sometimes they have questions too. So I just want to emphasize that this is available. All right, when? When is that technical assistance available? And basically at any stage during the project, during design or construction, all the way to completion. I'd like to emphasize that the sooner the better. Getting started early is really important rather than trying to go back and fix something later in the game. But I just wanted to say it is available through entire stage of your project. So I'm sure you're thinking, who provides all this technical assistance and how do I get it? All right, here is how to request, and I will drop this into the chat. Reach out to the CalEHP program contact. It could be someone in our outreach team, our operations team, marketing, it could be me, or a technical associate at any point before construction is complete. I'm going to say that one more time. At any point before construction is complete. That's the most important part. Next, a technical team member will reach out to schedule sort of an intake call to confirm how we can provide that technical assistance, and we'll connect you with the right program partner. It might be the team we've met earlier today at AEA. It could be one of our other team members, depending on your question. So I'm going to quickly launch a poll, and I'm going to share some contact information. And I will also answer some additional questions that have come up on program incentives. So if you can just if you're interested in getting technical assistance, just let us know. If not, I'm sharing our program's contact information here, and I'm going to paste this into the chat so everyone can reach out. Super. So I'm going to go to discussion now. I know we've had some additional questions on, have you found that the incentive amounts offered for the optional added items are typically more than the cost? Well, the cost at installation is sometimes higher, but the long-term energy efficiency savings for the property owner, for the residents, really outweighs it. So it's just a motivating factor to include those incentives early, to include that additional high efficiency equipment early in the game. We also have a question about our incentives and programs mostly for new construction. So California Electric Homes that offers the technical assistance is for new construction only. I can share some information with our guest today who asked this question, Coralie. We have another program very similar. It's a sister complementary program. It's Energy Smart Homes, and that does offer some incentives for whole building electrification.